Hello everyone, here today to start talking about templates. We've gone through a few of these model files here. We've done pavement, pavement projected, medians, end conditions, side streets, all of that stuff. And I've shown you how to create your corridors and add your templates and set everything up, split up the model files, all that good stuff. What I didn't do is go over the templates that I used. I kind of just grabbed templates that I had previously created for this job and used them to create my templates, or my corridors, I'm sorry. So while I kind of briefly went over templates that were used in those videos, I wanted to kind of come back and give a little more detailed view of some of the templates that we were using in these corridors. So I'm started out here today in the pavement model file here, and I'm going to take a look at the corridor that we have here and see what template we're using. So we're using this pavement typical one. So you can either click here and edit this template drop, and what this will do is edit this specific template drop and make it different from that in the template library. Sometimes you want to do that if maybe you have a very specific condition that you're trying to do on a side street or something like that. But typically what we want to do is come into our template, create template window here, and look at our pavement typical one. So here's the template that's being used. What I have here is I just called it a CL null. It's just a point that sits at the very center, the origin of the template. And that point is basically the parent for what all of these other points are based off of. So what we have is a right PGLN. If we double click that and look at these point properties, starting at the top, naming is pretty important when we do FDOT work. We can, let me close this a minute. I'm going to go to my preferences real quick. Options. So you can see when we open these preferences, these FDOT preferences, and I've got this Z because sometimes it bugs out and I had to create my own FDOT. But essentially every left, so we have these affixes, every point on the left side of the origin has this LT underscore prefix, and everyone on the right side has an RT underscore prefix. And that just helps us differentiate between the sides, but also make sure that the points have different names. So you can see if our right pavement EOP out didn't have this right, it would have the same name as this left pavement EOP out. So it's important to differentiate that, and especially when you're doing tie downs, which we can get into. Some of you may have run into the issue where you have this zigzaggy saw cutting thing that happens with your tie downs, and that will happen because it's trying to connect points that have the same name on different sides of the template. So we're not necessarily going to run into that problem because of the way that we've already split up our models, but that's just a easy example of why you would want to make sure that you have different names. And then obviously you just want to make sure that all of your points have different names anyway, because you might need to point control something or have constraints set up for one of them. So we'll go back into this right PGLN and take a look at what we got. So this is the right PGLN. You always want to make sure that your points have feature definitions. Another thing that's important in FDOT work is we have to deal with QC. Our models do need to be QC compliant up to 95%, so if you don't put a feature definition here, all of your points are going to be on a default level or some level that's not QC compliant. So you want to make sure that all of your templates have feature definitions that make sense. Super elevation flag. You use this sometimes. This is when you use the super elevation tool. And this basically says this is a point that can be, selected when we're doing super elevation. I've had some issues with that super elevation tool, and once we get out to these next few points, I'll show you how I handle super elevation. Moving down here, we have our constraints. So you can see this point is horizontally and vertically constrained to this CL null. So it's 11 foot right and 0 vertical. What this allows me to do is this point will be placed along the center line of our alignment, and it will follow the active profile of that alignment. So instead of putting this CL null up here and having it, up 2%, I want it here so I don't have to create a point control for this point, because I've just moved it horizontally over to where the PGL is, but vertically it will follow the active profile of the alignment that this corridor is based on. So that's that. Working our way down here, we can kind of work our way down points. So that's typically how we want to go. We want to go middle, out, and then top, down. So all of these points that are below, I try to make them constrained to the point above them. So you can see this point is horizontally and vertically constrained to the point above it, and it's horizontally 0, and then it's vertically constrained, let's see, 0.25 here for the pavement thickness. So I've also put a pavement thick label here, which we can use later when we're doing our parametric constraints. So anything that you put in this box here is something that you can use for a parametric constraint later. So that means I could change the pavement thickness for a certain station range within my corridor if I wanted to do that. You could transition it from 0.25 to 0.5, have it for over 100 feet, then have it be 0.5 for something for a distance, and then transition back. So that's the reason for that. The other reason for pavement thickness is I can come over here into my active template, into my parametric constraints. And if I come down here to this pavement thickness and double click it, it highlights all the points that have that pavement thickness parametric constraint attached to them. Let's say we go ahead and update our pavement design. And instead of 3 inches of pavement, now we need 6 inches of pavement or whatever. Just picking something so it's kind of dramatic when we change it here. So I'll do 0.5. The whole thing shifts down. So that's very helpful to kind of do a very quick change if you ever have an updated pavement design, or if you want to use this template on another project that has a different pavement design, you can just easily adjust the template you've already created to the new design. Let's change that back and we'll start working our way down here. So these are some points that I've put in here to assist with creating some of these other elements that you can see here. So you can see there's a white element up here, which is my DTM top surface, and my yellow element, which is my DTM bottom surface. So I'll be using those elements near the end of the project when I need to start creating my top and bottom surfaces for submittal. So you can kind of see I've put where the curb bottom is here, so that what's going to happen is this will, if there's going to be curb here, this will come to the bottom of that curb, and then the other template will come pick up and come over here, keep going. So I'm just trying to, I don't want this to come all the way up, because that's not how it goes. It stops here and goes in. So that's all this is really. It just has this curb thickness in, so that's the thickness of an E curb on the high side. And again, it's just constrained to the point above it. And in this case, it's not constrained here, it's constrained all the way to the top because I wanted to get the thickness of the curb, and then I just maintained the horizontal to there as well. So we can kind of work our way down to the bottom here, and this will get us to the bottom of our base. So you can see this point is constrained to this one here because we want the thickness of this base. So you can see I have my base thickness here. I can't remember if that's like 10.5 inches, I believe. So same deal as the pavement. And if we come over into our parametric constraints again, pavement base thickness, all these points have that same label on them. And if I change this number, all of them change. So that's something that's really helpful as well. So that's kind of how we go down. All of these points that go down like this go down in a similar fashion. So you can see this right curve is a little lower because this is F curve on the low side, so it's a little bit, the bottom of this curve is a little bit deeper. But as we come here to this right pavement travel out, so this one is kind of interesting. So it doesn't have a super elevation flag on it because it's horizontally constrained here, 22 feet. So that's our pavement travel width out. So that's got a label here too. If I ever needed to have a transition where we were going from two 11-foot lanes to 12-foot lanes, for example, I could have that parametric constraint there go from 22 to 24 over a station range of my transition. This vector offset is really handy right here. So what a vector offset is I've created a vector or a line between these 2 points, the right PGL in and the right pavement EOP out. And what I want this line, this point to do, is stay on that line. So its offset is always 0. So if I increase the slope of this point from 2% to 4%, and this comes down here, that point drops down 2 to stay on the line or the vector between those 2 points. So in that way I can, if I ever need to control my super elevation, I can control it using this point, and this point will just move along the vector created by those 2 points. So we can move out to the last point here, our EOP out. So this is our full pavement width. So we've got the 2 11-foot lanes plus a 7-foot bike lane. So that has a slightly different label here, pavement bike width outright. So again, if I needed to change that, let's say, our pavement width changed and our bike lane width changed, I would just adjust this value over the length of that transition. And again, we still have our super elevation flag here if we wanted to use the super elevation tools. So this slope is 2% from our right PGL in, and it has this label, pavement slope outright. So what I do is, you can kind of use the super elevation tools if you want to calculate your super elevation. Typically I will just use FDM values or AASHTO values or whatever values you're using for your project, and do some calculations in Excel to determine what my super elevation should be. So, the distance, so it'll give me the begin of the transition, how long the transition is, the distance of the full super elevation, and then the transition out. So I'll calculate all that in Excel, and then all I need to do is go into my corridor and create a parametric constraint that changes the value of this slope from -2 to, let's say, +2. So like if it wanted to go, like if you were coming around a bend that was to the left, this side would come up to super elevate 2% down, which is what we have on the project down here that we're working on. So you would change that parametric constraint over the distance of the super elevation transition that you calculated. So it would be -2 to 2 over that station range, and then it would be 2 for the station range of the full transit, or the full super. And then once you got into the end transition, the transition out, you would go 2 to -2 over the station range. So that's how I like to handle doing my super elevation. It makes it a lot simpler to just do it with parametric constraints and then have that Excel sheet as your backup. I find that to be a lot simpler. And that's pretty much it. This one has a horizontal feature constraint on it. I'm not sure why it does that. It doesn't really need this. I could probably turn this off. It might just be something left over from the stock template here. But if you wanted to change this to, let's see, roadway design. Let's find our pavement, like pavement EOPA. So what this is doing is it's going from this point. So we are at 40-foot offset. It's looking out another additional 50 feet for any reference that you add to the corridor. And it has to be on this feature right here. So if you wanted that, if you had like an outside edge of pavement transition that you wanted this to follow, you could make sure you have this horizontal feature constraint on, go add that as a corridor reference, and this point would follow that reference. And we go back to library. So one thing I noticed that I did on this project is I have my full pavement section, both left and right. And one thing I ran into is I was asked to do modeling for temporary traffic control. And I kind of had to recreate this pavement model file because sometimes you don't want to, you're not building the pavement on the right or the left, depending on which phase that you're working on. So in the most recent project that I'm working on, I created two corridors, one for the pavement right and one for the pavement left, and essentially just deleted one of these out of the others, so you have something like this for the left side. That would be one corridor. Something like that for the right side. That would be the other corridor. So that if you ever need to do traffic control or break these pieces out in some way, they're already broken apart, and you can use those as part of your traffic control or other broken apart pieces. And so it's basically the same thing. You just have two corridors instead of one. So you can always, I kept them in the same file. It's just two different corridors. So because they don't have end conditions, I wasn't too concerned about processing time. And I don't think you reduce your processing time all that much, whether you have one pavement corridor or two. But I mean, it's that's just one reason I've come across that I would split them apart. So let's close out of this now that we've looked at that. And obviously if you've made any changes, you can go ahead and save. So we did make that one change to that external reference. So what I can do here is I can come in here, I'm going to look, and that's going to show up as red because I made a change to the one that's in the template library. So because we did that, we need to come in here and synchronize template. Now the cool thing about ORD that's different from SS10 is you don't have to synchronize, you don't have to click every one of your templates. Now obviously this just has one template on it, but when you get into some of your end condition ones, you might have 10, 15, 20 templates where you've got brakes for side streets, or you've got brakes for driveways, or all these different end condition pieces that you might have added in there. And if you made changes to one that's used several different times, you would previously have to go click every template. But now in ORD, we can click the corridor, and that will update all the templates in the corridor, which is really great. So that's pretty much it for the pavement. I'm going to move on to the Pavement Projected, which kind of has a similar thing, but I'd like to show you how that works too. Now I'm here in the Pavement Projected file, and we're going to take a look at this corridor that we have here. So this is called Pavement Projection Median Full. So we'll go take a look at that template. And Pavement Projection Median Full. So you can see it's kind of set up similar to how the pavement one was set up. Just very simplified now. We don't have any depth. We're just trying to get this top surface. So the right and left PGL in are still set up just like they were in the pavement template. And we have this pavement crown median. So what I'm trying to do is just get our 2% crown. And so what I did here is we've got constraints from the left PGL and the right PGL, but they're both slope constrained so that it's 2% up from the left and 2% down to the right. And what that'll do is, because this is 11, this is 11, it'll just make this crown sit right above the CL null without us having to do any extra constraining there. But that's basically what I wanted to do anyway. And I think what I did on the one where I had some super elevation is, what's going to happen is, well, I think it's always like this, but what you can do is come out here to the end and see, I didn't even consider super elevation on here, but what I could do is put that same slope parametric constraint label here that I had in the pavement if I wanted to change that, which is what I've done in my actual project. This is just a kind of older template. So what I would do is kind of look at, let's go here. We'll grab this because I found it's very helpful to continue to try and use the same labels throughout all of your templates so that you always know, like, okay, pavement slope out right is my slope from my pavement. So if I need to change super elevation on anything, I can just go ahead and use that label. So I'm going to copy that label. Come back here. So we're going to apply that label here so that I could use this potentially for super elevation. And we'll go ahead and hit apply. And I want to do the same thing up here, so that if I changed this super elevation label here, that would change. Now you might not want to do that. It just depends on what you want to do as you super elevate through here. You could call this something different than this, because if you imagine, like, let's just say for example we did this. So how are we going to handle something like that if we have a median opening inside our fully super elevated section? Probably want to have some sort of low point in here, or you might flatten this out to something a little bit flatter. Just depends on how you want to handle that. If you have a lot of stuff like this, it might be a good idea to create another split PGL where you raise this right PGL up so that it is 2% up from the left one, so that everything just flows across here. This particular project, I didn't really run into anything like that. We don't have any median openings through my curve, so that's not something I really considered, but that's something that you might consider in your project if you do run into that. So if you get to here, you might want this to be something else other than this, so that you can control this slope independently of this one. So let's go back to this point again and change it back. So you can see that this point here is basically the same as our pavement EOP out, our right pavement EOP out, except this is more of a projection, so it goes out to 50 feet, whereas our other one went out to 40 feet. And I just wanted to make sure that this projection extended beyond the normal edge of pavement, so that if I ever needed to go, while I was doing detail modeling, I believe we used this in the side street detail model, I'm able to go grab the elevation of this surface to use for that. So if we want to come back here, Maybe we don't do this. It's just kind of up to you how you want to control this. Do you want to control this slope of this crossover independently, or do you want it to just come up here like that? I mean, if you're just, going down and you don't have any super elevation, this is pretty simple. So you might need to maybe you need to create another copy of this template and modify it slightly based on your use cases. So that's a pretty simple template. And we'll move on to the next one. All right, now we're in our median model file, and we're going to take a look at some of the templates that are in here. So we really only have one here in our corridor right now. I'm going to cover this one, and then I'm going to cover another kind of lessons learned that I've run across once we get done with this. So we're going to look at the curb type E median with widening. Curb type E. Oh, I can't find it. No, it's curb. There we go. All right. So we have our curb. Now I know this one says widening. I think that's because I copied this one from the Fdot. I don't typically include widening in here. When you look at the Fdot one, there's probably going to be 2 points stacked on top of each other right here. And it'll have a pavement section sitting here that has been condensed back to 0 width that is built to kind of widen out if you ever get into a turn lane or something like that. But if you go back and look at my median videos, I've kind of showed you how to handle that, where I create a separate corridor for that pavement, for that turn lane, and then I use the inside edge of pavement, I suppose, for the turn lane as a corridor reference to make one of these EOPNs follow that pavement. So we'll start on the left here. Again, we have our CL null and we have our right pavement EOPNs. I made these point names different than left PGLN and right PGLN because of what we just talked about. Sometimes this point is not the PGL. Sometimes it's shifted in for a left or right left turn lane. So that has to do with what's happening in the cross sections when we plot these and when we do our annotation. I don't want this point as it moves in here to be called PGL elevation. I want it just to be a regular elevation. So starting here, it's got the same setup as the pavement EOPNs. So we're on the left side. We're minus 11. So we're 11 foot right left of the CL and we're 0. So this basically puts these two points at the same spot as our left and right PGLN without having to do any point controls or anything like that. So the way you set up your template can save you a little bit of time in your corridor creation. So as we're moving on, this curb is basically just straight from the FDM, trying to keep, this point is referenced to the point above it. It's got its thickness, it's got its label. We continue here. So what I did here is it's 1.4. Now, even though this is supposed to be 1.5, what I don't want is this point to be directly underneath that point. So I've kind of just slid it over just ever so slightly in the model. We've got our gutter slope. And the reason I put that gutter slope in there is for our super elevation. And that kind of goes into the reason for this curb and gutter depth here as well. Because, as I said before, on this side, we're going to end up with a super elevation. And this curb will end up going from a high side curb to a low side curb. So we need to be able to adjust the slope down to the normal type E curb low side cross slope, and we also need to be able to adjust the thickness of here from its 6 inches to I believe it's 7.5 inches for a low side. So that's the reason for those constraints. And because I have those labels, which allow me to create parametric constraints, I'm able to go and add those into my corridor to adjust them. And that's pretty helpful. So we'll just go next here, and we're just going up to the face of curb here, and that is the 1.5 from here, and it's vertical from here, which is just straight out of the standard type E curb. If we go next, now we're at the top of the curb, and you can see I kind of just kept referencing this back to this left pavement EOPN because that was easier based on how the standards are set up. And it's just another vertical from here, just kind of easier to set it up that way. And then obviously here, this is kind of a little bit different because I didn't want to fix this distance because sometimes this might change. So what I did is I went horizontal from the point above, but I went vertical to the point out here so that if this point drops down, so does this point. And then we have basically the same situation that we had in the Pavement Projected, where we've got our slopes up at 4%. And again, this is kind of something that you could use in the Pavement Projected as well, is give them different labels that they could be controlled independent of the pavement cross slopes. That's what you have here. If I ever need to adjust these slopes for any reason to try and get things to fit as I enter a turn lane or something like that, I have that option. And there's a feature constraint on here, but I don't need it, so I'm going to turn it off. Sometimes those things are just left on from the default template that I pulled this from. And they're not really, obviously this wasn't doing anything, it was looking for like a median line at 0, so not really doing anything at that point. So you can just hit apply. Can also see, besides these curbs, we have the bottom mesh. So like I said, that point that's in the pavement that sits here where that bottom mesh goes down, now that bottom mesh connects there and goes to here. So that happens on the same side. So we've got our bottom mesh. And then same with our top mesh. Just kind of follows like that. So as of right now, I believe these top and bottom mesh elements are not passing Fdot QC. And I really wish they would, because I haven't actually gotten to the point of having to create the final top and bottom mesh files in an ORD project yet. But I would imagine that this is kind of going to be the easiest way to do that, is to grab my model, all my model files, turn everything off except for in the top mesh file, the top mesh, and then make a terrain out of all of those top mesh components. Once I get to that point, I will, gladly make a video on my findings on that. But what I've been doing for right now is kind of, if I've had to make a submittal where these were not passing QC, I just go ahead and delete these elements out of my templates and synchronize again to get rid of them so that they're not in the model anymore. And if I have to go back and put them in the template later, I can do that and then resynchronize. But for now, they're not passing QC, so just heads up on that. So I'm going to close out of this a minute, and they're going to have to save. So one of the things that I did in the median part of that modeling video is, we stopped, our template stops right here. We've got our median nose with our template, and then the grass is detail modeled, and this entire pavement section between here is detail modeled. The issue I ran into while doing cross sections, and again annotation, a lot of this stuff comes back to annotation, is that the annotation is not automatically labeling the cross slopes of this detail modeled surface here. So what I ended up doing is kind of looking at my cross sections. So like, let's say I have a cross section at 173. I will delete this model here, and it will only go to about here, so that just this little piece is detail modeled. And then I created another template for just the median pavement that runs from there all the way through to here. So let's say I have another section at 174 or whatever. Again, I'd maybe just come off of this line just to get me past the edge of the nose here. Have another construction line, and then that would finish off this little piece, and you could have your median pavement template run through here. And once you have a template through the median there, then the annotation will pick that up and label it for you. But what I want to do is go into my templates here and see if I have a template for this pavement crossover, which I do right here. We can open that up and kind of see what it looks like. It looks very similar to all the other pieces that we've been creating. It's got, so this one I put this CL null up here, and it looks like it's a little bit off actually. It needs to be adjusted. So you can see I kind of messed up with this one. It's slightly off, and we'll adjust this real quick to make sure it works. Just getting my settings here. So I want to make sure that this point, see, like it's at like 004, so it's very slightly off. So I'm just going to make sure this is moved, and this is at 0 and 1. I've noticed some of my templates have been doing that lately, and I'm not really sure why that happened, but just keep an eye on that. That's a good lessons learned, actually, is to make sure you look at the offsets of all of your null points or whatever your stuff is based off of, because that tended to happen to me a lot, where this was off by like a very tiny little bit. It's not a big deal because it's such a small number, but I was noticing some of my templates weren't lining up just right, and it was just a few random templates that had this little issue. So again, we can come here now that we know this is 1 above the origin. So I've just kind of modified this a little bit. It's just 1 down from the null. So we went 1 up from the origin, came out, and went 1 down. So it's the same deal, just kind of done a little bit different way. And then, so we've got those 2 points. You can see I named them something different again, so that they're not called. And these I probably could have called left and right PGL in, but what might happen is I might get like a double label here because I have 2 points that are called left PGL in. So just making sure that's a little bit different. And then this is like all the other ones that we've seen before, the 2% up, 2% down. And it's just like the other pavement model where we have our pavement depths with our parametric constraints. You've got your bottom mesh, top mesh, all that stuff is in there. So that's an example of that you create, and typically these don't change in width all that much. It's just a crossover. So sometimes you might maybe have a median crossover and a transition. So just have to be aware of that, being able to adjust these points as necessary. So let's go ahead and save this guy. And I'm not going to show how to add it in here, but essentially you would just kind of come into your median here. And yeah, since I changed that, we can synchronize the whole corridor, and that gets them. So yeah, all I would do is just, I would remove this detail modeling piece here. So remove the surface template, then delete the terrain. I would offset this line, single offset entire element, just enough so I can get it outside of this here. And then I would just have another line here that would follow my pavement projected. Because I have my pavement projected in here, I could just make it follow that surface. And then create a terrain based on this shape in here. Do the same on the other side, and then put the template using this one, the line that you've single offset partial here, and the line that you've single offset partial over here as limits, and then pop that template in there instead of detail modeling the entire piece. We can look at, let's look at these curb noses real quick because that's that's a linear template, but it's still a template. Oops, yeah, we can't, so when it's a linear template, you can't really use this bucket too much to look at it. Let's see. It's always hard to figure out how to click on some of these things because you end up, there's a lot of lines that are sitting on top of each other. So here we can edit the template drop. If we do this, again, we are editing the drop that is on that linear template, not the template that is in the library. So you want to be careful of that. If you want to actually edit this template and have it be reflected through all the things that you're doing, then you want to go edit the library and then synchronize. If you want to just change the template that's on this linear template, then go ahead and do your editing in here. I'm not going to do any editing. I'm just going to kind of run you through, but we've already kind of looked at an E-curb. That's all this template is just that E-curb that I've pulled out. And the only difference is we kind of have this ref point that's sitting at the origin, you can see. So that means that this point is going to follow the horizontal and vertical stuff of the line that we base the linear template off of. So that's pretty much it. I mean, we've already kind of gone over the E-curb. It's got the depth modifier here. We've got, all this stuff that we can modify. Once you've done your E, you can just save as your E and kind of delete everything in there and then bring this guy over to here, change that name to ref, and you're good to go. So I just hit cancel on that. Both these median noses are the same template. And the good thing about linear templates is it doesn't matter which side you build the linear template to, like if that one had been flipped, because when you build the linear template, you can choose which side the template goes to. So that's one nice thing about linear templates versus corridors is corridors, you might need to make sure that you have a left and right version of every template. But if it's just a linear template, then you can just have one version of it, whether it's left or right, and then flip it as necessary when you create the linear template. So that's it for medians. We'll move on to the next one. All right, here we are in the end condition right file. We can go through some of the templates that are in this end condition right file here. So we'll check and see what we have here. Look at this corridor. And we've got our sidewalk right and our sidewalk right ponti. So we will start by looking at the sidewalk right, and the sidewalk right ponti will be pretty similar to that. So we got these two guys right here. So again, we will kind of start with this piece of curb that you guys are familiar with already. We've kind of gone over that in the median. We've got our ref point that sits here at the 0, 0. And again, that ref point is, as you saw in the previous videos, has a corridor reference that attaches this ref point to the right outside EOP of the pavement corridor. So once we get through all the curb here, you can see we've got some text that's kind of jumbled up together here. And as I mentioned before, in the median corridor, or in the median template, FDOT sometimes has like the pavement kind of stacked up in here where that pavement width is set to 0 and it can expand out. So that's kind of true what's happening here, which we can show you. So we've got 2 points. We've got the right curb back out, and we've got the sidewalk front top out. So if I open that guy up, you can see it's the horizontal set to 0, but I'll set it to about 3 right now so we can kind of see what's happening. So it's a little bit convoluted here because we've got this bottom mesh and this top mesh. Well, what's in here is essentially your utility strip. And I keep it in there just in case I ever need to have a utility strip in this template, but when I finish working on the template and save it, I set that to 0. So we can see that the horizontal offset here is still to that curve back out, and we have our slope constraint, which is 1.5%. Typically you can go to 2% on your sidewalk cross slopes per ADA, but some projects that I've worked on have requested that we use 1.5% just to make sure that we don't exceed that 2%. So that's what we have here. And we've got our horizontal feature constraint in here looking for that front of sidewalk, and it's only set to 1. I don't typically use this template to have it where like we might be widening out the utility strip or something like that, but if I was having something where the back of sidewalk was varying, or we had a lot of transitions or whatever it was, you could include this horizontal feature constraint in here and set it to whatever width you wanted. So one thing to be careful of when you're doing these types of templates that are going to be point controlled to something else, going back to that pavement template, we can remember that the pavement was all the way out here at 40-foot offset. But this template is sitting here at 0-foot offset. So when it's looking for this horizontal feature constraint, it's starting at 0, coming all the way up here through this 2-foot curb, this 3-foot offset. So it's going from the curb that's at 2-foot right, and it's going out to this 3-foot, which is 5-foot right, and it's only looking an additional 1 foot. So it'll only look to 6 feet right of the center line for this. So if we wanted to make sure that we had a back sidewalk that we're looking for that might be 10, 15, 20 feet outside of the outside edge of pavement, we need to increase this number to something like 50 or 100. The other option is to move this whole template, so move this reference point all the way out to the 40-foot offset where it's going to be sitting, so it'll give you a better idea of where those offsets are going to be sitting. So if you've ever had issues with this horizontal feature constraint not working, that may be the reason, is that where this thing is sitting in space inside your template is kind of the same here, regardless of what point control you apply to it. So I'm going to leave that alone for right now because we're not doing anything. Our sidewalk is right at the back curb, and we'll just leave that expanded out for now as we continue. So typical with the pavement, we just drop down. We've got our 4 inches of sidewalk here. I've got this label on here for the back sidewalk thickness right in case I ever need to increase the thickness of this. That could be done due to coming into like near a driveway if you wanted to have a little extra thickness, or coming around a curb return where you needed to have a little extra thickness. Anything like that, you can control the thickness of the sidewalk with this constraint. We'll move on to the back sidewalk. So the back of sidewalk is 6 foot horizontal from the front of sidewalk, and we have another label here for another parametric constraint that we can control the width of the sidewalk. And then we have our back of sidewalk cross slope right here as well, with another label that we can control that with. And keep in mind, all of these points have feature definitions on them. So I don't want to keep reminding you guys that you need to make sure that all of your points have appropriate feature definitions attached to them so you don't run into QC issues later. And then we're going to go to the bottom of the sidewalk back, same thing as the front. We've got that back sidewalk thickness right. And then I'm going to save this little piece for last here, but then we have our buffer. So we've got our 2-foot buffer, controllable by parametric constraints in both the width and slope. And it has another horizontal feature constraint. I don't typically really need to use this too much, but it's here if I do. If I need to increase this range, I have the opportunity to do that as well. And then we have our tie downs. So right here, I just have 1-on-4 tie downs. Based on the constraints of this project, I know that we want to try and have 1-on-4s everywhere. So that's what I have, but I've come in here. Let's see if I've done it on this. So I haven't done it, and I'll show you kind of what I've learned here is, first off, you could always go, let's close this, because what I always do when I'm creating a template is I always go into end conditions here and this cut and fill right here. So this is your standard FDOT cut and fill, and what it does is comes out here and it does not have this end condition is infinite ticked. So what it's looking to do is it's going out horizontally 30 feet, which corresponds to a vertical difference of 5 feet at this slope. So if you look at the FDM, you can see that if you're doing slopes, for example, you would have 1-on-6 fills up to 5 feet, and then you would have 1-on-4 fills up to 10 feet, and so on and so forth. So that's the way these are all set up. Let's see if we can look at this. So these are just end conditions. It's looking for the active terrain model. And they have various priorities on them. So priorities like what it's going to do first, what it's going to do next. I'm not entirely sure why FDOT has higher priorities like this. I imagine you could start at 1 and go 2, 3, 4, but they have 28, and then as you go down 29, so that's the next line it's supposed to draw, the next line, and then it looks like they want to try and fill first and then cut if they have to. So that's the way the priorities are set up. So see, like these will start decreasing. So it wants to do the 1-on-6 fill, 1-on-4, 1-on-2, 1-on-3, and then it wants to try and do the 1-on-6 and then back out. So that's what that priority does. Priority can be kind of helpful in that manner too, if you want to do something similar in yours, which one it's going to follow. So what I do is I just take this template and I'll just, I'll have this sitting here and I'll just I'll grab this this thing. You can always grab stuff from here and bring it in like that and just snap it to that point right there. So you always want to make sure that you have your fixes on when you do that. So you see I did, and it's just sitting here in space. That's fine. So what I typically end up doing is, for this one, like I would go ahead and I'd delete the 1-on-2, 1-on-3, delete these 1-on-6s, and delete these other guys. So then I can come in here, and I want this end condition to be infinite. I know I'm gonna do 1-on-4s, so I can check that, and then I can just kind of bring this into a more manageable distance. Just something that's not quite so crazy. So that's kind of what I do there. I go back out to this other one, make it 2.5. 2.5 seems good, just enough so I can see it. It's not too small, not too big. Make end condition is infinite. Boom, now we got that. So that's basically what we have here. So delete that. The other thing I started doing is I've realized that sometimes I need to be able to transition this slope, maybe what we're doing here, into the pond, for example, like, or wherever you might need to transition the slope, like if you have a cross drain with a head wall or something that you need to kind of fix, or whatever it is. So what I do here is, since this is a negative slope, I will do negative tie slope right and hit apply. So that lets me control the slope of this. I mean, obviously it's going to sit there at 1-on-4 standard, but now I have a parametric constraint. The reason I put that negative there is because this one's negative, and then when I go to here, I can just grab this and remove the negative. It's because that's a positive slope. So now whenever if I need to change the slope for whatever reason, I can just have a parametric constraint, limits of the transition, limits of the full width of that modified slope, and then transition back out. Now we can start taking a look at this handrail. So what we have up here is this right handrail test. element here, and if we click onto this endpoint, we can see that we have do not construct is toggled. So I'm going to untoggle that real quick and turn this on. So we can see that end condition is infinite, so that means we've just drawn this at a certain spot, but it's going to reach out and search infinitely for whatever it's looking for. What it's looking for is a specific feature, in this case pipe handrail, guide rail, aluminum. If you needed to change that to a different feature definition, then you could go ahead and do that. You might want to make a different template or a different search line. You could copy this search line and make a different one. What it's doing is it's looking out for that feature definition. It would find that feature definition if you added your handrail element as an external reference to your corridor. So essentially what that external reference is going to do is make this element actually show up. It'll actually draw. Currently, if we go test this thing, and I'm going to turn this do not construct back on again so that it disappears, but it's still there, it still exists. I want to go test this, and what we can do is we can draw this feature definition. So if I hit draw, you can see if it might have been better to leave that on, but you can see like it's right here, it's above this line. So if it searches out and finds that external reference somewhere, it's going to draw the handrail with the sidewalk extension there. If it doesn't find it, this is what you're going to get. So this is the typical situation. Typically, you don't have handrail. There's no external reference finding handrail. So if you have no handrail, you're just going to end up getting this. But if you add an external reference for handrail that's on the feature definition that it's searching for, it's going to find that. So we can hit close, and we can see that these elements are on right now because this element is still sitting here. When we attach this, in a corridor, this element doesn't actually exist until it finds something. So what we've done here is we've tied this element to a parent component being this handrail test. So whatever happens with this parent component is going to happen with this one. So that handrail element and the element down here for the sidewalk extension is also a child of this parent component right handrail. So if we turn that off, and let's turn this back on, so actually construct it, and if I delete it, those things go away because they were children of that parent. The parent's no longer there, children go away too. So that's a good thing to remember if you start creating these relationships. Delete the parent component of a child, the child components are going to go away too. So we'll Control Z that. So sometimes I will do that with some of my components here. Like I'll make the curb is a child of the utility strip, for example. And the utility strip is a child of the curb, and so on and so forth. So you start with the element that everything is based off of and work your way out. And that way, there's some tricks you can do later that will make that useful. Like if I wanted to just have curb, I could put a switch on here that would turn off this element, in turn turning off everything else outside of it, because it's linked to that. So if this element's not here, neither is everything else that's a child of it. So that's something interesting to think about. So we've kind of gone over everything in this template. I'm just going to leave it that way and not save. What we also wanted to look at was this pond tie. So it's pretty much the same. I guess you can see here I've got a asphalt-based curb pad here. That's something you can delete or keep or whatever you want. Sometimes you're going to have that, sometimes you're not going to have that. In this case, I do have it. I believe we started adding these curb pads after I copied this over, so this is the way we've been doing it. And it's really easy to, you can create your own template for this curb pad and then just snap it here so it all just works. It's easy to add to an existing template if you need to do that. So everything's pretty much the same in here except for this end condition. So this thing is no longer actually an end condition. This is just a normal component. I just called it right pond tie, put it on slopes. It's just kind of hanging out there. It needs something to control this right pond tie, and if you watched my pond video, you would be able to see that we used a corridor, we used a point control to tie this to a corridor feature on our pond so that this ties down to the pond corridor through the limits that we specified. So that's really the only difference. What I could have done is gone back to here and I can create, I'm not going to go crazy here, but create this component here. And I don't want it, and then finish. So let's say this is our pond tie. And I can do a new null point for a switch. I'm just going to call this switch test. And I'm not going to put a feature definition. You can put, it's probably a good point to do, I do template null point for anything like that. And the cool thing is you can right click on this and do add constraint, full constraint. And I'm going to constrain it to this point directly below it. And I'm just going to give it some constraints. So now it's fixed to there. To make this a switch, I want to call this horizontal. So we'll just call this switch test. Okay. And that's for parametric constraints. So you would use the parametric constraints to do what I'm going to detail here. So now that we have that, I'm going to put some rules on these. So I need to create a rule, add test standard tie on. So when I create a rule, I like to kind of say what it's going to be for. So this is going to keep the standard tie on. And I want it when the absolute horizontal, meaning like the distance between, the absolute distance between the points that I specified being the switch test and the point directly below it is 0, the standard tie will stay on. Okay. And then now that we've created that rule, you gotta select it and add it to this condition here. So I've done it for that one. Now I can use that same rule down here. Selected rule. Okay. And then for this one, let's say I want to create a new rule. We're going to add one. Test pond tie on. I'm going to say this is the absolute horizontal of this and this equals 1. Okay. Test pond. And when we do that, that point disappears because the absolute horizontal distance between this is not 0. So what we can do, now we have 3 things that we can do with this switch. If I come in here and I change it to 1 and hit apply, the standard tie goes away and now we have the pond tie. Also, if I put any other number in here, 2, 10, a million, I usually use 10 because that kind of tells me I want to make everything go away. So now I've turned them off. I've turned both end conditions off. Maybe in this case I need to detail model everything that's outside this point, so I don't want any end conditions out here. If you you could even just bring this back to 2, same thing. But as soon as it comes back to 0, we get that back. So that's one way you could do this. You could have a switch that controls this, or in my case, I just decided to create a brand new template and just do a template, just trade out the template instead of doing a switch. So I'm going to close out of this, and I'm not going to save anything. So that pretty much covers the two elements or two templates that we had in here. So far we've covered the pavement templates, the median templates, and the unconditioned right templates. We're not going to cover the unconditioned left templates because they're essentially the same thing as the unconditioned right templates, just flipped on the other side of the road. So the final thing I wanted to cover is some of the templates associated with this side street. So we'll jump into the side street file next. Okay, so we're here in our side street model file, and there's a couple different corridors in here. We've got a corridor for each of the curb ramps, and we've also got this main corridor that kind of fills in the gaps between them. So we have this type F return left and this type F sidewalk left. We just got done looking at the type F sidewalk right, so we're not going to dig into the left because it's basically the same thing. We can take a look at this return left real quick, and it's not really anything that we haven't seen already, but I just wanted to show it to you. Type F return, oops, sorry, type F return left. So we just have our standard F curb, and in this case I just have the 2 foot buffer here. So we've got our buffer width, we've got our buffer slope. Again, we've got labels to control things. We've got a horizontal feature constraint if we need to have this go out and find a shoulder line. And then we have our standard 1-on-4 ties here to just go down to existing. So pretty basic stuff here, very similar to the sidewalk left. And again, if we needed to, we could come put this label in here like tie slope. So this would be negative tie slope left, and we'd put that positive tie slope left on the other point, or you can come in here and manually change this if you need a different slope. All options there. So I'm going to come in and look at this curb ramp right here. Oops, selected the wrong one again. Got to get the right corridor. So this blue is telling me that this corridor or this template is not in my library, but it's in this file because I brought it in from my civil cell. So I created it using a civil cell. So it's in my civil cell template library that I have elsewhere in another file. But I can still go take a look at what's going on in here, and I can still edit this too. When we take a closer look at this template, it looks pretty similar to our curb sidewalk template, except for a few different things that we got going on here. So the first thing is these 2 points. So I have my left curb back out, and right now this is just showing our standard curb height, but I have this label in here that's going to control that curb back height to lower the curb back down through the ramp. So let's just do this for a second, kind of show it how it drops down. There's this other point in here, curb back full, that keeps that full curb back height throughout the entire limits of this template. And that point allows us to control this. And so this is 7 feet for our curb ramp width per the standards, and we have 1.5 foot slope up to that. And that allows it to kind of just fit into all of the other sidewalk templates around it. And then once we start moving out, we're going to here. So this is 12 feet from the left curb back full. And that gives us a little more distance than we need. Typically this back here is 4 or 5 feet, so I kind of went with 5 feet for the maximum, but it has a horizontal feature constraint that's looking 12 feet back to the right for the back of sidewalk. So if the back of sidewalk comes in, if I have an external reference that I'm referencing, this will come in as well. So you can see we still have our 1.5% slope up here, making sure that sidewalk all fits. This is just looking broken for right now because I moved this down. Something's not working right there. That's really all the difference is here. So these points all in here kind of have more labels on them. So we've got our curb back height. So that allows me to control the curb back through the limits of the ramp. We've got our curb face offset and our curb face height. So again, this curb face has to drop down as we get into the ramp, but it also has to change offset because this face comes down and meets here, this flow line. So as we go through the ramp, using our parametric constraints, we're able to do that. And here, we've got our gutter depth and gutter width, because as you go from F curb to drop curb, the gutter width, the gutter offset, and the gutter depth change as well. So these 3 points are all changing as we go from F curb into the drop curb and back out. So by adding these labels in here and referring to the standards and figuring out the math and what all the dimensions should be, I'm able to go in and say, I want this to drop down over this distance, I want this to drop with it, I want this point to move, how everything needs to move so that everything looks nice and flush when you do it. And that's something I've done in a civil cell, because you can see there's a lot of parametric constraints that go into that. So now that we've kind of reviewed that template, I'm going to hit cancel, and we can look at all the parametric constraints that are going into making this one curb ramp function. So if we look at this curb ramp, let's expand this out a little bit. A lot of stuff is happening here. So we've got our F curb there. You can see the back curb drops down. The face of curb drops down, but it's also pushing out towards that gutter line. The gutter line changes, everything is moving, but right here, for that 4 feet, we have our full drop curb and everything looks nice and clean in there. And you can see that the sidewalk is, that ramp is depressed down too, and how the sidewalk wraps around here. So all that is from our external references we got here. So we've got external references for this to kind of match up with that. We've got external references for our back of sidewalk. So that point that was referenced to that curb back full also had an external reference on it, or horizontal feature constraint on it, same thing, that was looking for this curb ramp line. So you can see those are here, added here in the external reference. So you can see all these parametric constraints, all these external references, all this stuff. That's a lot of things to be doing for every curb ramp, which is why a lot of people don't really like modeling curb ramps. But if you can figure out how to do it once in a civil cell, then you can just plop these things right in here and you have everything. You've done it once, you know it works. You just add it right in there. So we've got this kind of the same thing going over here. This one's a little bit more complex, but that's something maybe I can cover a little more closely in civil cell creation. That's coming in a future video. And so I think we've covered the curb ramp templates. And I was thinking about covering a driveway template today, but what I'm thinking about for the next video is doing a driveway civil cell video. And when I do that, we're going to show how to do the 2D, the 3D, but there's going to be some template design that goes into that to make sure that we get the template correct so that everything works. So this finishes up going through all or most of the templates that we've used while creating this 3D model. And be on the lookout for that driveway civil cell video, hopefully coming soon. Thanks for tuning in. Hope you guys liked it.